Next lesson is titled Properties of Rhombuses, Rectangles, and Squares. So for this lesson, guys, we're still talking about parallelograms. So all of the properties of parallelograms that we talked about in the last lesson still apply, but we're just getting into more specific types of parallelograms here. So we're going to be talking about rhombuses, looking at our definition here. A rhombus is a parallelogram with 4 congruent sides. All right, so you can see that example here. A rectangle is a parallelogram with 4 right angles. And then a square basically has both of those criteria. So it has 4 congruent sides and 4 right angles. Right? You guys are very familiar, probably more so with rectangles and squares, but we're throwing a rhombus in the mix as well. Right? So this Venn diagram might be good to jot this one down. So just remember, a square is actually, you could categorize a square as a specific type of rectangle or a specific type of rhombus. So a square just has both qualities, right? All 4 congruent angles, all of them being 90. So it is a rectangle. And then it has all 4 congruent sides, so it is also a rhombus. All right. So now getting into some specifics about rhombuses in particular. So if a parallelogram is a rhombus, then its diagonals are perpendicular, right? So perpendicular, again and again, I mentioned this word, I think 90 degrees. So if you have a rhombus, we know that when you draw out your diagonals, they will intersect to create 90-degree angles, right? And just recognize too, because a square is a specific type of rhombus, this also applies to squares. And then our next theorem, if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So remember that term bisect, meaning cuts in half. Right, so if we're given a rhombus and we are to draw the diagonals, say for instance, angle 2 was 40 degrees, I would know automatically that angle 1 is also 40 degrees, right? Because your bisector cuts your angle in half into 2 smaller congruent angles. Right, and you can see this list here, lots of congruent angle pairs. So let's apply this and solve some problems here. So if we look at this example here, given it's a rhombus, I mean, I could include this too, but we'll assume it's a rhombus. What are all the missing angle measures? So let's take a look at the first one, or the first theorem that we talked about. So we know that our diagonals create 90-degree angles. So that means I can label angle 1 as 90. Right? The second theorem tells me that my diagonals bisect each vertex. So I see that angle B is 58, or sorry, the smaller angle at angle B is 58. Remembering too, your opposite angles of parallelograms are congruent. So that means, yes, this is 58, and then it's going to be the same thing across from my parallelogram. So this angle 3 will be 58 degrees, and angle 2 will also be 58. All right, so actually I'll write that as a list. So we have almost all of our angles. So we're just missing angle 4, but now let's look. Notice that angle 4 is just within this triangle. We now know that 2 of our 3 angles are 90, 58. So we add up those 3 angles, it will give us 180. Subtract that from 180. Oops, sorry. We get the measure of angle 4 is 32. There we go. Then the measure of angle 4 is 32. All right, so you guys know how to solve for missing angles. We just now have some extra information to be able to solve for rhombuses. So for this one, I'll have you guys pause the video, try it, and then we'll go over it. Right. Hopefully you made the connection, remembering that a rhombus is just a type of parallelogram, guys. So we know that still our consecutive angles add to 180. So just start with figuring out what R is in general. So I know that 104 plus the measure of angle R equals 180. Subtract 104 from both sides, I get the measure of angle R is 76, but then we drew the diagonal RP, right? Which is right here. So then just divide it in half. We know that that diagonal is bisecting angle R, so angle 3 is going to be 38, and all of your others are also 38. So we know that 3 and 4 are congruent. And then we also know that R and P, those are opposite angles, so those are generally congruent. And then when you split up P, we know that those two smaller angles, 1 and 2, are also going to be 38. So all of your angles are 38, okay? Or all of your numbered angles. All right, next theorem. So now we're going to be talking about rectangles. So if a parallelogram is a rectangle, then its diagonals are congruent, right? So congruent meaning equal here, not necessarily 90 degrees. Remember too, guys, that square is a type of rectangle, so this would also apply to a square. So where you see here, you have your rectangle. When you draw in diagonals, we know that each diagonal will be congruent to itself, right? Versus just parallelograms in general, we just knew that the diagonals bisected each other. This is still the case, but now we also know the diagonals, those longer segments are also congruent to one another. So let's apply it to this problem right here. We're given this rectangle, RSBF. We know that SF is 2x plus 15, so that's this diagonal here. We know that RB is 5x minus 12. This diagonal, what is the length of the diagonal? So we want to find the length of the diagonal. Solving for x is going to come in handy first, though. All right. So let's set SF equal to RB. We know we can do that because we're given it's a rectangle. So I'll set 2x plus 15 equal to 5x minus 12. I'll get x on one side of my equation. Add 12 to both sides. Add 27, divide by 3. X equals 9. Now be careful here. Don't say it's B. Make sure you read the question carefully, guys. So look at it. We're trying to find the length of the diagonal, so you just need to plug this in to either expression, either the 2x minus 15 or the 5x minus 12. I'll do 2x plus 15. That looks a little bit friendlier. So I'll plug in 9 here. 18 plus 15 is 33. Right? So making sure to set up and solve your equation correctly, but also make sure you're answering the correct question. All right, you guys pause the video once again and try 3A and B. All right, here's all the work for this problem, guys. Make sure you solve for x first and then plug it in to solve for ln and mo. You really only needed to plug into one expression, but I like to check my work and make sure that I solve for x properly. So if you plug it in for ln here, you get 43 units. If you plug it in for mo, you also get 43. Right? The answer for A is at 43. And then for part B, what type of triangle is PMN? So let's look at PMN as this triangle within our rectangle. So we know it's actually going to be isosceles. The reason for that is because we know that LN and MO are congruent, right? So we know those diagonals are congruent to each other. And we also know because a rectangle is a type of parallelogram, those rules for parallelograms apply as well. So we know that LN and MO bisect each other. So that means MO is cut into congruent parts, so is LN. So each of those are going to be congruent. You can see you have two congruent sides within triangle PMN. All right, I think this is our last problem for the lesson. So if you're given a coordinate plane, you should be able to argue in some way if you were to plot your points, whether you have a rhombus, rectangle, square, or none. All right, so let's take a look at this example. Let's plot our points first. So E is at -2, 3. I'll label that E. F is at 4, 1. G is at 3, 2. Is that right? 3, 2. Oh, sorry, 3, -2. I was wrong. And then H is at -3, 0. All right, I'll connect my points. All right, so first off, I can pretty clearly eliminate rhombus in a square because I can see that EH and HG are not congruent. Okay, so I can cross these out. So rhombus square, I can just say the sides are not all congruent. I mean, you could use distance formula. If I asked you to use distance formula to prove it, you guys could go through that process, but just glancing at this is pretty clear that those are not congruent. So it looks like a rectangle, right? But what makes this a rectangle versus just any parallelogram? 90-degree angles. Okay, so I'm going to write down, oops, sorry, can't spell, rectangle. So but we need to prove somehow that we have 90-degree angles. So remember, when we're dealing with a coordinate plane, we know that we can prove that we have 90-degree angles if we can show that we have perpendicular lines, right? So do we have perpendicular lines? If we do, their slope should be opposite reciprocals. So don't forget about that. We have covered that. So let's check and see if our slopes are opposite reciprocals. They look that way, but let's prove it. So let's look at HE. So second HE. So this is just analyzing the slopes. For HE, I have a rise of 3 and a run of 1. Right? So 3 over 1 is my slope there. GF, a rise of 3, run of 1. So that's also positive 3 over 1. We'll look at HG now. So I have a rise of negative, or actually, you know what, I'll break it down. Let's check and see. Negative 1 over 3, negative 1 over 3. Okay. And then EF, my slope is negative 1 over 3, negative 1 over 3. All right, so did we flip our sign, right? So remember, opposite reciprocals, flip the sign, flip the fraction. Did that occur? Positive to negative, right? We have slopes in the positive direction, slopes in the negative direction, and we also flip their fractions. So that is true. We have opposite reciprocal slopes, so we do have 90-degree angles. For each of our vertices. So we have a rectangle.